When doing scientific research, scientists make a hypothesis, and then they design an experiment to test that hypothesis, and then they produce data, and they form conclusion based on those data points. Where this gets more complicated when we get into upper level sciences is that not all data is created the same. That data needs to be proven to be statistically relevant. And we're going to look at what statistical relevance means, and I'm going to teach you how to use a really important tool that you'll use a lot in college. And that tool is called a spreadsheet. And there's several different types of spreadsheet software. The go-to one is Microsoft Excel. You guys don't readily have access to Microsoft Excel, so I'm going to teach you how to use Numbers instead, which is just Mac's version of spreadsheet software. Google also has spreadsheet software. Their spreadsheet software is called Sheets. From my experience, Sheets is terrible. It probably does the same thing that all the other ones do. I just can't maneuver Sheets very well. All of them are basically the same with the same setup. Just with buttons in different places. So I'm going to teach you all about how to use spreadsheets. You will use them a ton in college. All scientists use spreadsheets all the time. Not to mention people like my wife did accounting stuff and she uses spreadsheets all the time. So spreadsheets are a huge important tool in many, many, many industries. Chances are pretty good that you're going to use spreadsheets in your future. So let's learn how to use them. Sorry, statistics is boring, and sorry, spreadsheets is boring, but it's part of doing real live grown-up science. Here is your lesson on how to do this. I'll put timestamps so that you can jump to the parts of the video that maybe you're most stuck on. Timestamps will appear here. There you go. The first thing you're going to want to do is open Numbers. I had to open a new file there, and this is a brand new file. And the first thing I'm going to do is type a column for names, because we're going to say that the data we're collecting is from groups, and these are all the names of group members. And I'm going to type in all my group member names. There they are. Look at that. Okay, great. Next, I'm going to put in the categories that we're measuring, and we're measuring different colors of things, how far different colored dyes travel through some gel, I think is what this data is from. So what I'm going to be doing here is taking an average. So to take an average, first we're going to type average in our little title box over there on the left. Then what we're going to do is click on the box below our first column of data. And then what I'm going to do is hit the equal sign on my keyboard. If you're on a tablet, like an iPad, I don't know what you have to hit, but you're going to have to figure that out because I don't ever use spreadsheets on tablets because it's cumbersome. But if you're on a laptop, you hit the equal sign. It'll pull up your function bar right there. And you can see over on the right side of my screen, I've got a bunch of mathematical functions I can use. If I start typing in average, it should pop in there and just fill in with like, oh, you want to take an average? And then it wants to know what I want an average of. So I click on that top box in the column, that 13, and then I'm going to drag down. Now sometimes it doesn't want to drag correctly, so you have to like unclick on that box and then click on it again, and it'll let you drag and select all. But see what it did? It filled in B3 through B10. See how the spreadsheet is like a grid, and B3 through B10 is what it's taking the average of, and there it did it. See, 14.475. Then what I'm going to do is click on that box, and I can drag the same formula across by grabbing that side handlebar. It's a little yellow dot on the side of the box, and I drag it all the way across the row, and it took the average of every column. It just figures it out. It takes the average of everything. It saves you a lot of time of calculating averages. Next thing we're going to do is figure out standard deviation, which is a nasty mathematical formula. It's actually not that bad, but it's a little cumbersome to calculate individual standard deviations. You've probably done it in a math class before. But I'm going to do the same thing. I'm going to click the equal sign on the box that I want to work in for the column of numbers I want to work in. I want standard deviation. Well, standard deviation, I'm going to have to look for it in the functions I can do. So I go over to that where my cursor is on the right. I'm going to click at that search box on the top eventually. There I go. And I'm going to type in standard deviation. And it's going to have a bunch of statistical tools, many of which involve standard deviation. But I just want plain old standard deviation, and I can click on it. And below that, it tells me, oh, yeah, that's standard deviation. If you look on the lower right, it tells you the definition of it. And then it wants to know standard deviation of what? Well, same column numbers. What is that? B3 through B10 is what I'm doing. And then I click that green button there, and it does it. Boom. Gave me my standard deviation. Then again, I grab the handlebar, drag it across, and it takes a standard deviation of every column of my numbers. So far, so good. We've done average, we've done standard deviation. Next, we need to figure out, I think I do count next. What I mean by count is number of groups that I had, or number of data points that I had. So if you look, we have 1, 2, 3, 4, 5, 6, 7, 8 groups of people that submitted data that we took the average of. So that's really what I want. And I could just go across and type 8 in all the boxes. But I can also tell my spreadsheet to do the count. Count of what? Count of those 8 boxes. Obviously, you don't need the spreadsheet to do this. But if you had like 1,000 data points, it might be a handy tool to know how to use. So that's how I did count. Count is just telling me I had 8 people. Now I want standard error. Standard error from the mean is, I'm not sure, something that Numbers has a tool for, but I know how to calculate standard error. I think I'm going and looking for it right now, and I don't see one that's obviously just calculate standard error. But the good news is I know how to calculate standard error because they give you this cheat sheet on the AP exam, and on this cheat sheet it tells me the formula for standard error of the mean. See it right there? It says sex. Anyway, so what we're going to do is take standard error, and standard error is calculated by taking your standard deviation and dividing it by the square root of the count number. So what I did is I took B12, which was my standard deviation box. I'm going to divide it by, open parentheses, the square root of, look, square root, I'm typing it up in the upper right-hand corner because I want it to do square root. I don't want that top one. I want just plain old square root. Boom, square root of what? Square root of what the value in that box that's in B13. And then close the parenthesis. And then, yep, that's what I want. And then I did it all the way across, and it gave me standard error from the mean for everything. Yay. So I can just type in mathematical equations in the box. Oops, I just did a dumb thing down here. I'm trying to do mathematical equation for 2 times the standard error because we're going to need that value too. But well, right now I'm typing it into what this thing is, and it is standard error from the mean, which is 2 times SEX. X with a little line over it means mean. So this is standard error of the mean. Hurry up, me. There we go. If I didn't subscript it, I would go crazy. Okay. Anyway, so 2 times, what I want to do now is do the math of 2 times the standard error, which was box B14, right? But I accidentally started trying to type the mathematical equation without hitting equals first, and then it doesn't give me a function box. So I got to pull up the function box first by hitting equals, then do 2 times that box. And then, yep, that's what I want to do. And then I grab the little handlebar on the side of the box that I just calculated, drag it all the way across. It'll do the same calculation across all of the columns. Now I've got 2 times the standard error of the mean everywhere, and I'm going to need that number later. Last thing we're going to do is have this spreadsheet make us a nice graph. So I'm going to plot the 6 different categories, the 6 different colors, and I plotted their average. So I did that by selecting one entire row and the other entire row and just saying, hey, put it in a chart. Chart option was up there on the top. If you look at the top of the Sheets menu, there's a selectable tool up there that says make a chart, and then it just does this. And it will spit out this chart. Now, what I would need to add to this chart is the name of the bars in my bar graph, because I did a dumb thing when I typed in my names of each one of my categories. I did it in the B2 box instead of the B1 box, and it went to pull the names out of the B1 box. So it's got the wrong thing selected. So what I did is go down to category labels, and I'm deleting all the reference box B1, C1, D1, whatever. I'm deleting all of those and saying, no, take it from B2, C2, E2, and then it'll say, oh, okay, I get it. Then I should name those categories based on those boxes, not the boxes in the gray box up at the top there. The other annoying thing you have to do in Numbers is like pull it over and select like yes, indeed do that. But now look, all of my little bars on my bar graph are properly named for each one of the different dyes and how far those dyes traveled through our gel. Good, cool, neat. We made it make a graph. Congratulations. It gave me a nonsense title, so I just deleted the title because I'm not interested in that right now. The other thing we're going to need on this graph, and the reason we did standard error, is because we're going to include standard error on our bars now, which means I'll click first on our graph, and then I'm going to go over to the right and see how it's got menu options on the right, and I'm going to click on the box for series. And in series, it's got several things I can do. One of my options is error bars, and I'm going to add positive and negative error bars. And it just pulls up random values, but I don't want random values, I want custom values. What custom values do I want? Well, I want the custom values for error. I want 2 times the standard error up and 2 times the standard error down, which is what I calculated in that last box. So see how I'm selecting the last box that's 2 times SEX? Those are going into my positive value, and then I have to select, yep. And see how I did that? And then I'm going to do negative value. Watch, I'll do it again in case you missed it. I'm going to erase that 10 because why did it just randomly pick 10? But I want 2 times the standard value down as well, standard error value down as well. So I'm clicking on all of those. Then I have to grab that little dot in the negative box, pull the whole thing over, which this is the dumbest system, and then select, yes, that's what I want, and then it clicks back in. And boom, now I've got my little standard error bars. The standard error bars are important because if the standard error bars overlap, it means that that data is the same as the other data. So if we look at like green and purple, for example, their error bars overlap each other. Statistically, that means those 2 dies traveled the same distance. Yellow and green, their bars don't overlap, therefore those 2 are statistically different from one another. So that's how scientists make scientifically accurate conclusions and how spreadsheets are done. I hope this helped. Here's a silly video of cats. Have a nice day.